Thanks for coming out on a Tuesday night. It's really actually lovely weather, so I'm serious, right? It's not 20 below. My name is Kate Dickerson. I'm the founder and director of the Maine Science Festival. This is our poster for this year. I'm just going to give a quick informational scoop about the festival, and then we'll dive into why the cool stuff and why you're here. So the Maine Science Festival, we're entering our 5th year, in case you couldn't tell from our big number 5 that we have on the poster. This festival is like an art festival or a film festival, but it's all about science. So if you enjoyed science in school, you should come. If you didn't like science in school, you should come. If you're not really sure, you should come. Pretty much, I've staked my claim on, with more than 70 events and activities over 5 days, I will find something that you will like to do. We run a whole bunch of different programs. We do forums like this. We do hands-on activities. We do workshops. We have art exhibits involved. This year we're going to do Science Trivia Night. So if there's anybody here in Bucksport who wants to host a Science Trivia Night and be part of the first ever statewide event for the Maine Science Festival, let me know. We will provide all the questions and answers. You just have to run the event. And I haven't seen the questions and answers yet, but I'm assured that they will be excellent and pub quiz-like. So that's the scoop. We run it, the festival is the 13th through the 17th of March. The entire festival we run for free. We ask for this year we're asking for a suggested donation of $5 if you feel so inclined, but we don't charge for this event because I don't think the amazing thing that is Maine science, and I realize that's not very eloquent, I don't think we should have to pay for the privilege of learning about that from the world and national leaders that we have, some of whom you'll see tonight. I can speak unabashedly proudly that Maine has some of the best researchers in the world, and I'm pretty excited that we've got some here tonight as well. So without any further ado, we're going to go right into land-based aquaculture. Oh, an excellent question. Thank you. Sorry. The festival is in Bangor, Maine. We run most of the events. Let me rephrase that. We have events throughout downtown Bangor and at the Cross Insurance Center, but on the Saturday of the festival, we are at the Cross Insurance Center. That's the only day we're at the Cross Insurance Center. The rest of the weekend, we're in different locations throughout downtown. The one event that we do charge for is our headliner event, and this year we're bringing in a podcast host and producer from Science Versus, and they are going to talk about science versus UFOs. So a little bit of levity, and also some actual real deep dives into what we know about extraterrestrial visits and whether they've actually happened or not. That'll be at the Gracie Theater at Husson University. I forget that everybody doesn't know when it runs, because I've been thinking about it pretty much every waking hour. All right, so Michael Pietrak, I'm going to I do this every time I run an event. I try to read as much of the bio as possible, not to bore you, but so you get a sense of kind of how amazing these people are that are giving us their knowledge and their time, and also because I just think it's really cool to hear what people have accomplished. So you can tune on or, wonder when Kate's going to get done babbling, but I just want to give you the reason why I do this, because I think it's really impressive, and no one seems to get tired of hearing about stats for quarterbacks or for point guards, so we're just going to do the same thing for scientists. Michael Pietrak is a research associate with the U.S. Department of Agriculture in the Agriculture Research Service National Coldwater Marine Aquaculture Center. Did I get that right? Okay. Mike got his BA in biology from Ithaca College, where he was introduced to the wonderful world of parasitic copepods and their importance to aquaculture or fish farming. After working at several marine labs around the country, he received a master's in science from the University of Maine in marine biology in 2002 and went to work for the Maine Aquaculture Association. At MMA, Michael did applied research, outreach, and extension to support Maine's aquaculture industry, including founding the Maine Hatchery Roundtable in 2006 and research on composting fish poo. He earned a PhD in marine biology from the University of Maine in 2013, looking at how fish diseases interact with other animals on a multi-species fish and shellfish farm. He continued working at the University of Maine in the Aquaculture Research Institute as a postdoctoral scholar until joining the USDA in 2015. Mike's research interests have focused on developing new applied techniques for economically and environmentally sustainable agriculture. His current research is focused on developing a range of non-drug-based tools for managing sea lice in Maine's commercial salmon industry. Do I still have that right? And Mike, thankfully, is back from furlough, so I'm really grateful that he was able to squeeze us in after having lost a month of work. So a big thank you to Mike. see if we'll get you up here. And that should work. I'm sorry. See, I'm out of practice because I haven't done this since last March. We're going to have 3 presenters. They're going to go about 10 minutes each, and then we're going to dive in for questions, which is where you guys, you all can come in and pound them with as many questions on what they presented until about 8:30. So thank you.
Great. No. Thank you. I'm going to try to go through this. So Kate asked me to talk about the science behind sort of what we call RAS, recirculating aquaculture systems. As she mentioned, I work for the USDA at the National Cold Water Marine Aquaculture Center, which is located right here in Franklin, Maine. This is our building here in this big green roof. Right next door is the university's Center for Aquaculture Research, Cooperative Aquaculture Research. Together we form sort of 2 large recirculation-based commercial scale systems in the state. So, as you can probably imagine, there's a whole lot of science that's involved in aquaculture in lots of different disciplines, from biology, engineering, chemistry, physics. I didn't put economics up there, but pretty much any discipline you can think of is really involved. I'm going to try to go through that in 10 minutes. I'm going to fail. I do it in about 12, so I apologize for talking fast. I'm going to really focus on engineering tonight, and if anybody's interested, I highly recommend Recirculating Aquaculture. This is the 4th edition now that's out by Dr. Mike Timmons, Dr. Todd Gerdat. Mike Timmons is at Cornell, Todd's at University of New Hampshire, and Brian Vinci is at the Freshwater Institute. And they're important because they do a lot of USDA research as well. There you go. So anyway, this is kind of the Bible, so I highly recommend it. Now, my audience participation. How many people have a fish tank at home? I have one, right? Okay, you're doing recirculating aquaculture at home, right? This is recirculating aquaculture. And so really the science challenge for us is to go from this to maybe something that looks like this, right? Much, much bigger. But if we go back to our little aquarium, we can get through this here quickly. We need a tank. You saw some concrete tanks in that last picture. We need a filtration system here that you've got. Typically our filtration we break down into 2, mechanical, that's the nice fuzzy stuff on the outside of the filter. And biological, we don't really use in this, we use a chemical. That's the activated charcoal that's inside, the black stuff inside the filter. It gets kind of expensive to try to do that on large scale. So we go with biology there. You need environmental control, like your heater here, right? And not in the picture, but we need air. So we got to get some gas into the fish. If we look at sort of a schematic for a big recirculating system, right? All the same pieces are here. We got a tank here in the middle. We have air. We're not just talking about putting oxygen in, but talking about removing other gases from the system. We've got monitoring and control environmental systems. We have all these systems here for getting rid of physical filtration of our waste. And we have the biofiltration, or that chemical filtration there. There are 2 things on here. We've got biosecurity, disinfection. I'm not going to talk on those. That's Ian later in one of the other talks. So a tank is not a tank. You think that these things are sort of simple. It's something that just holds water. There's actually a whole lot of science that goes into how does the water flow in that tank so that hopefully it's self-cleaning. That's nice. Who likes to clean? I don't. Right? So we want to do that. Round tanks are really nice for being self-cleaning. But square tanks and rectangular tanks are much more efficient in terms of a footprint space. So when you're building something indoors, you want to use all the square feet and maximize their usage, right? So some clever folks have come up with some designs, such as this is called a mixed cell raceway, and we use sort of these counter circulating water here to try to get the effects of a round tank, and we can use fancy gizmos like Doppler current meters and actually look at what does the water flow look like inside of the tank. All right, we need those environmental control systems in there, heaters, chillers, those are important. We want to try to have constant water temperatures and recirculation. Water quality is really important. You or I can walk into a room and know, is there good air, is it bad, is it too cold, too hot? We can feel that. can't put our hand or our face or toes in a fish tank, right, and figure out, is that a good environment for the fish or not? So there's a whole lot of water quality and chemistry that we need to do on a regular basis to monitor that and make sure that it's a good environment for the fish. And then I think, one of the interesting things, and one of the things that's really getting exciting where there's a lot of work in there, is starting to integrate a lot of technology into this, right? So we happen to use robot feeders. We have about 8 people who run our big fish facility. And so we use robot feeders here. Well, a lot of these water quality testing now, we can put those in probes in the water, and there are computers that are recording it, and it calls my cell phone when something goes wrong, right, so that I know when there's something wrong. I saw somebody about 5 years ago who had took cameras off of an Xbox and built a system where he could watch his fish from 3,000 miles away and in the dark and feed his fish from his cell phone, right? I mean, that's pretty cool, I think. But so there's all kinds of things like that that are going on in there. Filtration, mechanical filtration, lots of different options out there, mostly stolen from the wastewater treatment world. Drum filters up here, really large in size. These are fluidized sand bed filters here on this fish tank. This is just a drawing, but this is actually the type of system we use in Franklin, incline beds. Biological filtration, the name of the game in biological filtration is space. So we're trying to do all kinds of different ways, and again, I'm showing you one because this is the technology that I'm told they're going to be putting in here in Bucksport, these moving bed biofilters, but there's 3 or 4 or 5, 6 other ones out there. But they involve essentially something like plastic media of this type that's trying to generate space for bacteria to grow on to break down those waste products. Aeration, right, our last one in here. Again, they plan to use low-head oxygenators here is what I'm told. Pretty simple technology. You've got a plate up top with a whole bunch of little holes in it, makes it rain through here. You pump oxygen in from the side, pure oxygen in, and that gets absorbed into the water. So it's a pretty efficient means of transferring oxygen into the water. Other gases come out and go out the side. You collect them down here. Other ways of doing it, you can use something like a species cone with liquid oxygen. Again, we primarily use pure oxygen here, so that air stone that you have in your aquarium is pretty inefficient at moving air, like 2% gas exchange, right? So we use pure oxygen to bump up oxygen levels to the right level for the fish. But this, essentially dissolves 100% of that oxygen into the water, so very effective. We do use air stones, but they're a little different, and they make a really fine bubble to really increase that dissolution. And then finally here, I'm going to take 2 slides and just talk a little bit about what we kind of do nationwide in the USDA in terms of research and aquaculture. We happen to be in the middle of just starting to write our new 5-year research plans. And so we target 4 primary species groups in research around the country: catfish, hybrid striped bass, salmonids, including trout. It's probably one of our largest groups, along with catfish, and shellfish. We're just going to talk about salmonids now. 2 major areas that we're focused on: production issues and disease. Production-wise, what we do, it's primarily what we focus on here at the National Coldwater Marine Aquaculture Center. Our primary mission is raising and developing and selecting the new genetics for North American strain broodstock lines. Some of the stuff we're really getting into now with these new RAS systems coming online is evaluating our fish, how they grow in net pens, which is what we've always selected for, versus how they're going to do in these RAS systems. Do we need to develop new genetic lines or not for that? And we also are interested in sort of management practices, feed ingredients, testing those, production systems, essentially anything that you can think of that I kind of touched on and whizzed by in terms of interactions, environmental interactions, is fair game in production systems to work on. A lot of that work is done down at the Freshwater Institute in West Virginia as well. So hopefully I'm under my 10 minutes here or close to it, and I'll I guess, take questions at the end. So thank you very much.
Thanks, Mike. Next up, we have Jen Fortier, who's a native of Ellsworth and has worked with a variety of marine and aquaculture businesses in Down East Maine, including DMR in Lemoyne, the Shaw Institute in Blue Hill, and Acadia Harvest, a land-based aquaculture company that produced California yellowtail and Franklin for the New England sushi market. She received a Master of Science degree in marine biology from the University of Maine's Aquaculture Research Institute in 2014, as well as bachelor's degrees in marine science and microbiology. So while I pull this up, can you all hear all right? Is it okay? So. And we're good. Now you can see why I have other moderators besides me who know what they're doing. When you do the video, all you have to do is click on this, and it should go up.
You're awesome.
Okay?
Okay.
So.
All right. Hi, everybody. Pardon me, I'm recovering from a cold, so I'm probably not going to shake your hand later. Thank you for coming. I know a lot of you. I've met you around town. I've talked to you at different events. A lot of what I'm going to talk about here you may have heard already. I kind of want to give a brief overview and then talk a little bit about where we're headed. So Maine is the largest marine aquaculture state in the U.S. And what we have right here, so this is all of the current leases in the ocean right now. So we've got oysters, a lot in the Damariscotta. We've got experimental leases, some of which are things like scallops, razor clams, and then we've got the finfish aquaculture, mostly in Down East, especially up around Eastport with all the cooked salmon pens. So what we're looking to do here is really to increase domestic production. There's a lot of aquaculture production in the world, but we want to bring it here. We want to increase it here so that not only can we provide a fresher product for us that isn't being shipped across an ocean or two, but also it can be more secure, it can be more traceable. There have been some incidents with seafood coming into the country being mislabeled as a species, either one that's not supposed to be fished or one that they can charge more for. So being able to take a fish from egg to plate in one facility and bring it right to the grocery store, bring it right to your table is really one of the things that we're looking to do. In addition, we can have lower costs by not having to bring it across an ocean. When you buy a farmed salmon in the market, if it's coming from overseas, it's coming from places like Norway, Chile, Iceland, Scotland, and probably about a quarter of the price that you're paying is the airplane ride to get it here. So we're hoping that we can really break into the market that way. So another reason that we chose Bucksport is because of the potential for this revitalization of this industrial site. And being able to have something like a paper mill that we can come in and reuse a lot of what's there saves us a lot of work, but also uses the facility in a way that I think is going to be really innovative and is going to be something that other places can look to. We have an industrial site. What can we do with this? Also bringing large-scale recirculating aquaculture into an area. Hopefully we'll be promoting a lot of other accessory businesses. We talk a lot about the value chain in aquaculture. So that's the supplies that are coming in, things like feed, things like power, but then also what's coming out on the other end. In addition to the fish, we're looking at the waste sludge from the recirculating system, as well as any processing waste that we have from the fish. And those have a lot of interesting applications for various types of fertilizer or composting or uses for other areas. And so we also have this great thing in Maine where we're so close to these major seafood markets. Here on the East Coast, we have Boston, we have New York, and then we have Miami down in Florida. And so a lot of the seafood that's coming into the U.S. is coming in through these three ports. And so having the access to that distribution network that's already there is great for us. And in addition, I was at a meeting a couple of weeks ago, and they were talking about how Maine seafood still commands a premium price. If you go to a market out of the state, if it's oysters from Maine, if it's salmon from Maine, you're talking another $1 or $2 a pound for salmon. You go look at the cooked salmon in Hannaford right now, and it's $12.99 a pound, where the stuff that's coming from other places in Canada are maybe 10 or 11. So that's a brand that we really want to focus on and that we really want to promote. That's where we are. So recirculating aquaculture systems have been around for a long time. They've been used in a lot of small-scale applications, predominantly for salmon smolts, so raising the fish from egg to a smolt that is then stocked out to a net pen in the ocean. And so what we're looking at here for this industry is we're starting to see more land-based and larger scale. So the technology has been around for a while, and it's gotten better and better as the years have gone on, but in addition, we're starting to look at building it bigger and bigger, and how do we scale that, and how is that done, and how is that appropriate? And so there's also been a lot of research labs that use it, and then also some conservation, like the Craigburg Fish Hatchery in Orland, where they have a flow-through system, so they're not doing a lot of the recirculation, but they're using it in order to restock these genetic strains that are native. And so what we're really looking at is maybe 20 years ago, this is what we were looking at. Ocean net pens have lower operating costs, they're easier, they're quicker to set up. Land-based RAS, if you want to scale it up, you're going to have really high startup costs, really high operating costs because of all that machinery and that extra work. But what we've seen over the last 10, 15, maybe 20 years is that the cost of doing business in ocean net pens has started to increase. And that's because of a couple of things. As they continue to have licenses for these net pens in places like Norway and Scotland, they are running out of places to put them where it is appropriate for the licensing and for the environmental concerns. So the price of those licenses keeps going up. In addition, they have a lot of problems with sea lice and parasitic diseases and other outbreaks. And so they're having losses, they're having additional treatments. And also, you also have to worry about escaping into the wild, and there have been some high-profile escapes worldwide over the last few years. Now, at the same time, land-based RAS is starting to get cheaper, and the reason for that is not only are you using the water more efficiently to the point where you're recirculating about 90% of the water you're using and just adding that other 10% in, the equipment that you use has gotten much more efficient at what power you use and how much you use. I mean, we're running pumps, we're running pure oxygen 24/7, 365, and we have backup systems upon backup systems in case anything happens to that. So I think those are kind of the main things that have helped land-based RAS become more efficient and more affordable, and I think that's one of the reasons that you're starting to see more and more land-based systems globally. And in addition, as Mike was talking about, the nutrition is getting better for what we're feeding to these fish. The genetics are getting better for what strains of fish we're growing. And so while I don't think that they're ever going to be they're getting closer. I think net pens may always have a little bit of an advantage, especially when it comes to starting up and building these things initially because there's such a high start cost for land-based aquaculture. I think it's gotten close enough that that's one of the reasons that we're seeing a lot of this industry really grow. So why did we choose Bucksport? A lot of people ask me that question. And I think it's because it was the perfect location for us. We are able to reuse the system that was already in place from the paper mill, both to bring water in from the river and out from the river. That saves us a lot of time. We don't have to go through an Army Corps of Engineers permitting process because that's already been approved. We did go through the wastewater discharge permit with the Maine DEP to approve the discharge that will go through that system. And we received that permit in November, and so we're all set for that. But also having both the saltwater and the freshwater capacity here on the site, there's a gravity-fed line from the paper mill that goes from Silver Lake right down through to the site. To have that there is really useful for us, and so that means that we can take freshwater from Silver Lake and saltwater from the river, which is kind of brackish, kind of in the middle, and mix it to the specifications that we need. And so that gives us a lot of freedom to do what we need to do without having to make a lot of big changes to the water. And just as a note, up in that upper corner, you can see sort of what the mill was using from each of those sources versus what we expect to use. And so I believe our first phase 1 permit is for 4.65 million gallons per day of discharge. Excuse me. And so there's a lot of things on the site here that we're going to be able to reuse, but there's also a lot of things that we're having to kind of pick and choose and look at what's the best thing going to be for us. And that's a lot of the things we're doing. So what we're talking about in terms of a RAS system here, we're just looking at not the tanks, as Mike was saying, but really this is where a lot of the improvements have been, is in that system part, the wastewater treatment part, very similar to some of the wastewater treatments you see for human waste. That's where some of the technology was kind of borrowed from initially, going back far. But as you can see in a facility like this, every life stage has its own room, which is biosecure from the other, and Ian's going to talk about that in a little bit, about pathogens and how we do this very safely and very cleanly. And so if we have an issue with one section of the facility, it won't spread to the rest, and we'll have a lot of good protocols in place to make sure we get on that right away. So one of the things that Mike alluded to is actually something that I think is really cool. And so not only can you look at what is going on in your facility, having a temperature sensor and an oxygen sensor in every tank. You go to Mike's workplace and there is like a control room like you would see in a spaceship. And if there's something going wrong, there's something big and red and flashing, like, pay attention to me, something's going wrong. But I think it's really interesting that not only are we able to respond to problems in a facility like this very quickly, but it also gives us a ton of data to work with. And us science people really like data. We like having it to play with and try to model, oh, well, if we change this, what would happen? And so having this continuous monitoring in a large facility like this gives us the opportunity to look at what we've done in the past. What did we do wrong? What can we do better? Why did this batch of fish grow faster than the other one? Was their temperature more constant? Did they get a better oxygen saturation? So there's a whole lot of different variables that we can look for, and that'll make us that much better as we keep going forward. And I just want to plug for this cool little company. They're in San Francisco in Norway right now called Aquaculture. And what they're doing is they're using machine learning, so artificial intelligence in a computer where the computer looks at the image and is able to delineate where the fish is and actually measure the fish in the picture without you having to take the fish out of the tank and measure it yourself. And so keeping the fish happy and stress-free is really important for good fish health and production in a facility like this. And if you can measure the fish in the tank with a camera without having to handle it, that's one less thing that is going to make those fish stressed out. So it's just a cool thing that they're doing. You can find them online. They post a lot of their stuff about what they're doing, and so they're just looking at a lot of image recognition. It's a really cool, cutting-edge kind of thing. Am I doing on time? Okay. I'm doing good. I got 2 slides. All right. So just a little note about our salmon. We are committed to a not genetically modified organism fish. We're looking at the premium market in the U.S. and especially here in Maine. We do currently have up to a 10-year offtake agreement for a distributor for our seafood, but we are looking to reserve some of that so that it will be available here. I mean, I want to be able to work at the mill and go buy it at Hannaford down the road. That's my goal. So I really want to make sure that we're not shipping it all off somewhere else that is going to be available here in Maine as a Maine company. And so what we're going to be doing initially for this phase 1 is we're going to be doing head-on gutted fish. So we're not going to be doing any filleting. We're not going to be doing a lot of processing in the facility. We might do that later on, but we got to get the first couple of years right and under our belt and get everything moving smoothly, and then maybe we'll look at that or partnering with someone in the future. And like I said, we are looking at different ways that we can use our different waste products in the future. So next steps for us is to finalize that purchase and sale agreement. It is a big, complicated set of documents, and Jason here in the front spends a lot of time on it. So once we are able to sign that purchase and sale agreement, AIM will be responsible for bringing everything on the site down to the current grade, and then we'll be able to get in there. We're probably going to be doing some blasting, a lot of grading. We have a couple of permits left, and that I'll talk about for a sec, and then getting into initial construction. We're still crossing our fingers for early spring start of construction, so that's exciting. And we are taking a lot of photos of the site as we go, and I actually have a video for you guys in a sec. And so we want to keep you guys involved, and we want to make sure that you guys know what's going on, and we want to continue to be really transparent with you. So like I said, we have our wastewater discharge license from Maine DEP. We've submitted our water quality monitoring plan for them to review that was due on the 1st. And then we also have to talk about a dye study. So that'll be this summer, I believe. And so that'll help us get an idea of the local currents in the area so we can better understand our discharge and where it's going and how it's diluting. We do have the land-based aquaculture license from Department of Agriculture, Conservation and Forestry. But they are in the process of kind of figuring out what that license is going to be. They only got jurisdiction for that about a year ago, so we may see some changes to that in the future. And then also a lot of what we're working out of is SLOTA. And so that is a state program, and that helps people understand what is your noise pollution, your light pollution, your traffic, your groundwater. So it's a lot of the engineering and a lot of the site design and planning that's going to help us have a lot of information available, as well as the VRAP. And so that's an EPA brownfields program that if we find anything additional on the site after we've already done our due diligence, that gives us the opportunity to mitigate that ourselves in conjunction with the agency. And so that's just a way of us saying, if we find anything, this is how we're going to deal with it. And just a plug for ADAPT, if you haven't seen ADAPT, bucksport.org. It's a great economic development report that came out in November, all about Bucksport and all about that site. So I am going to come down here. All right. So this is a video that we got.
I expect at some point we'll get to do it before and after, which will be pretty neat. All right, and our last speaker before we dive into the questions is Ian Bricknell. Ian is the Lieber Professor of Aquaculture Biology at the University of Maine and comes from North London in the United Kingdom. Ian initially trained as a medical microbiologist working for the Public Health Laboratory Service, where he received extensive training in human immunology and parasitology. In 1989, he was offered the position of higher scientist at Fisheries Research Services in Aberdeen in the Fish Immunology Group, where he worked in the field of fish health, developing fish vaccines and new and improved diagnostic methods for the protection of disease in wild and farmed fish. Just as an aside, the other reason I like to read this is because I had no idea some of these things existed, and I think it's really cool to find out that they're out there. So. In 2007, Ian accepted the post of Lieber Professor of Aquaculture Biology at the University of Maine, and in 2009 was appointed as the first director of the Aquaculture Research Institute. Since arriving in the USA, Ian has established a new aquatic animal health disease research group and has expanded his research interest to include lobster health. Ian is committed to helping the working waterfront in Maine to ensure a sustainable and dynamic aquaculture industry. And we will put you up here. It's all yours.
Well, thank you everybody for coming, and I'm always honoured to be asked to talk at the Maine Science Festival. And as a merciless plug, because I'm here with an audience, I'll be talking on beaver fever and swimmer's itch at the main event, which is going to be looking at some of the parasites you can catch swimming in our water, just for fun. I like disease. So biosecurity is an interesting concept. I wrote a book on biosecurity in 2006. And if anyone wants a PDF copy of that, an Adobe document, drop me an email and I can send it to you. But one of the big differences between land-based aquaculture and ocean-based aquaculture is the ocean is full of disease. You're exposed to everything that swims by. You're exposed to birds flying overhead and pooping. You're exposed to people sailing past with potential pollutants or whatever. When you bring your aquaculture on land and have those aquariums, as we've seen in enclosed buildings, you get much more control and much less disease issues because your biosecurity is so much higher. So what is biosecurity? Well, it's the procedures that are intended to protect both humans and plants and animals from organisms, especially pathogens that may be harmful. And we can summarize that as a way of keeping the bad bugs out. Now, it's not just about disease, although disease is a big issue. Here we've got a carp which has died of a disease called spring viremia of carp, a very serious disease in areas where carp are farmed. But it also includes organisms that can have an adverse effect on other species. We have a big problem with green crabs here that came over in the 1800s and have been plaguing our coastline ever since. And of course, Australia has the cane toad, which was introduced to eat cane beetles deliberately and ate everything but cane beetles. And of course, this is the topmouth gudgeon, a fish from Asia that got into Europe and now dominates some watersheds. So again, biosecurity is not just about pathogens. It can be about keeping out injurious animals and plants like parrot feather in our rivers. When disease happens, and I was taught, and anybody who's done any disease, that there's a classic disease environment, and it hasn't changed that much. You have an animal that can get the disease. It's called a susceptible animal. And you can do things to protect that. You can vaccinate it, for one thing. And you have to have an environment that is suitable for the pathogen to live in. And pathogens, like the fish, have environments that they do well in. They can be particularly dirty or rich in nutrients. And that's the bad fish tank that Mike was talking about. That had the good ones. That's a bad one. And then that bad environment and that susceptible organism has to come into contact with the pathogen. And only where they cross over here will you see clinical disease. When they don't cross over, it doesn't matter whether you've got a suitable environment and a susceptible organism. If there's no pathogen, it can't happen, and vice versa for all of those. So we have these interacting environments that we have to consider when we think about biosecurity. And we also need to know how disease spreads, and simplistically, disease spreads in two ways. There's vertical transmission, where the disease is carried in the gametes. When they mate, the sperm or the eggs passes those gametes to each other, and the offspring that are born are all infected. And that happens with certain viruses in humans and cows and fish. And then there's horizontal transmission, which is the classic way disease is spread. If we sat too near to Jen, she'd horizontally spread her germs to us today by shedding them in her breath and her sneezes and whatever. And sometimes you can aid these with structures which are called fomites, and they're things like dirty nets, dirty Wellington boots, dirty hands, which is just a way of transmitting them between tanks. And then we have to consider what the pathogen is. And there's three real groups. There's what's called an opportunistic pathogen, and that could be a pathogen when the fish or a mammal is out of condition. And there's a tin can that has fermented and blown, and if anybody ate the contents of that tin can, they'd probably be very ill. But the bacteria in there are probably fermenting bacteria, and they occur naturally. Used properly, you can make pickles out of them. But in this kind of condition where there's no air, there's probably a lot of toxins in there, and that's bad news. You have things called facultative pathogens, and these are pathogens that can become a disease issue when the conditions are right. And if I swabbed all of you in this audience, I would find the bacteria that causes strep throat in about half of you. But you have no symptoms. It's only when you're stressed or run down that you get a strep throat. And they must happily live in the environment. They're not going to do any harm unless conditions are right. And then the last type, what's called an obligate pathogen, and they can only exist as a pathogen. And this is Exingula, which is a parasitic isopod that lives in the mouth of fish. And this guy has to be a parasite because it lives in the mouth and steals the food of its host as it feeds. So that animal can't exist outside the mouth of its host. So that's an obligate pathogen. But you can control those diseases with all sorts of things, and vaccination is one, and pretty much every farmed fish in the world, catfish or tilapia or salmon, get a vaccine, and I spent a lot of my research career optimizing how fish are vaccinated and looking at how you can control diseases without using antibiotics, for example. You can use medications like antibiotics, although we're tending to move away from them because of the issues with antibiotic residues and, of course, disease resistance. We look at nutrition. Well-fed animals do well, and we know much more about nutrition today than we did 30, 40 years ago for fish. And our diets have improved tremendously. And then biosecurity, that concept of keeping the bad bugs away from your valuable stock. And this is from the Merck Veterinary Manual. And there's three types of biosecurity. There's conceptual biosecurity, and it's when you plan your site. So you don't put your site next to a road or a shrimp factory where there may be the risk of contaminants getting in just from passers-by. And, you know, there is a famous case in Hawaii of a farm that dismissed a disgruntled employee. They grew shrimp, and he went down the local supermarket, bought a bag of Thailand frozen shrimp that commonly have a disease called white spot virus in shrimp, and threw them over the fence into the ponds. So that's conceptual biosecurity. You think about how high those fences have to be, or other ways to prevent those kind of accidents happening. You then have structural biosecurity. You have fences, you have lockable doors, you have key codes that only certain individuals that work in those buildings there have access to. You have ways of disinfecting vehicles that come onto the site. All those are what's called structural biosecurity. And then procedural biosecurity. You have good staff training to make sure you do simple things like wash your hands between rooms or between procedures. And I don't know whether you've noticed, medical doctors now wear scrubs rather than shirts and ties. When I was little and used to go to see a doctor in the 60s and 70s, always had a suit and a tie. We found out in the 90s that one of the big ways diseases are spread from patient to patient are the end of doctors' ties, when they lean over a patient in the hospital and go, "How are you going, Mr. Smith?" And of course his tie dribbles all over the sick person. Then he goes and sees Mrs. Smith, and the same thing happens. So we've changed that, and that's a procedural biosecurity example. And all these are applicable to RAS systems. So let's look at the external barriers. These are two external barriers that I know about. One is great, have a good gate. And have instructions on the gate that you must report there, and then you have to have your car disinfected before you even come onto the site, because the owners of the site don't know where you've been beforehand. You can ban the movement of older or certain fish onto that site. You should quarantine your new animals. You can do blood tests for disease on your stock. You should quarantine and inspect those new animals and make sure that those animals are certified specific pathogen free. You restrict access so people don't have the rights to get onto a site very easily. I once investigated a disease outbreak on a halibut farm, and there's a halibut were catching a virus that's common in salmon, and they had excellent biosecurity. The staff were superbly trained. They all had great barriers, apart from the site dog, who had free access to everywhere, and you would follow the owner around. He wouldn't go through the footbaths because they were wet and full of chlorine, so they stung his feet a bit, so we would hop over them. And when we did the investigation, we got the virus out of his feet and his well, I won't say his feet, we swabbed his feet, we didn't cut them off. And we found the virus on his fur and on his foot pads, And of course, he was wandering between the buildings, and he was the source, he was the fomite that was spreading that disease between the two sites. But of course, people just didn't think that he would be the issue, because all the staff had all the training off pat. So be careful with those kind of things. You need to clean and disinfect equipment. And here is an ultraviolet system that's disinfecting water entering a RAS system. So it's taking water from the environment and then cooking it with high-dose ultraviolet light, which is very good at killing pathogens, before it's used and going into the fish. You can manage pests, of course, by making sure that you filter out parasites, for example, like sea lice. So you will never get sea lice in a RAS system because you can filter them out before they actually get onto your fish. And of course, that pathogen-free water is key to achieving that. And you can do that by having a well system, for example, where it's naturally filtered. You should always quarantine your new animals when they arrive, and quarantine comes from the word quarantina, and it means a period of isolation. It's usually for humans and cows and things, it's going to be 40 days, but we're a nice 97 degrees Fahrenheit, and we stay that all our lives. Fish don't. Fish are the temperature of the water they live in on the whole. There's a few that aren't. So if it's cold in the winter, then the diseases will take longer to appear than in the spring or the summer. So you have to make sure that your quarantine is appropriate before you use those fish in your breeding program, for example. And it's temperature dependent. And an ideal quarantine system is something like this. It's a very compact system. It's got minimum decor, so it's easy to clean with disinfectants. There's no substrates in the tanks. They're just glass bottomed or concrete, depending on what you've got. It's very easy to clean with a central drain that goes into the wastewater treatment. There's controlled access. Only those people that are trained to work with those high-risk fish are allowed in. Each tank has its own equipment. The tanks are isolated with covers from each other, as you can see here. And each tank is an isolation unit. Think of it like an Ebola hospital for fish. And the unit can also double as this receiving area when there's new fish in, so you can contain any dirty water that's coming from outside. And some animals may be in quarantine all their lives, and you just take their offspring and use those in your fish farm, because you don't know the full disease history of those animals, but you know the full disease history of those babies. Internal barriers are just as they say. You know, you make sure each unit on your farm has a specific role, and they're isolated separate units, and you restrict access. So the people who are working on the marine side wouldn't necessarily get access to fresh water, and vice versa. You make sure each one is covered by a foot bath, and you have big signs on the doors that say, wash your hands, use a foot bath. Each unit has personal protective equipment. You have the dedicated sets of Wellington boots and clothing. You have pest control that's specific to that and the dedicated equipment. And you monitor the fish health. Once you put your fish into the tanks, you don't just leave them. You go and get people to test them once a month, once every 3 months, depending on your testing regime, so you know your fish are remaining healthy. You can vaccinate against many common diseases too, just in case there's a breach in biosecurity. And if any do die, you remove them straight away and you get them autopsied. And be ready to treat if necessary. So you should have access to a veterinarian, and you should have those regular emergency chemicals ready to go in case the worst happens. And of course, there's plenty of disinfectants out there. You've got things like sodium hypochlorite for bleach that you can use on boats and tanks, all the way down to things like ozone and iodophores, which you can use for your Wellington boots or whatever. And there are some that are specific plastics and some for fish waste. So there's plenty of choices of those disinfectants that you can use to make sure that your equipment is disinfected between use between those rooms. And of course, another thing is the staff training component. Most people think a foot bath, you dip your feet into it. But for real biosecurity, you have these training manuals where you actually have this step-by-step how to disinfect your feet. This is a stuff called Virkon, and it goes from pink to blue when it's exhausted, so there's an indicator so you know that it's tired. And it's a case of you scrub off the dirt, you actually then clean your boots in it, and then you can proceed into the building. And of course, you also have to consider work practices. And normally, you always look at your most vulnerable fish first, and those fish that are in quarantine last, and you work what's called clean to dirty. So you always work, with the quarantine unit being the last of the day, or you have specific dedicated staff to each unit, and never the twain shall meet. And if you have several species on your site, you work from the most delicate, the most disease-susceptible species to hardier species. And this is important in these multi-trophic systems where you may have oysters and seaweeds and fish all living together. And this could go into a diagram, and this grey area represents the outside world, and this green area represents the farm. So initially, you source disease-free stock for your farm from outside. You then go through those physical barriers. You have your staff training, you have your health monitoring, you have your quarantine, you have your health plan, you make sure you're using high-quality, disease-free foods. You have good water quality, and of course, that goes on to safe discharges, because you don't want to take your material and have live bacteria or pathogens going and being discharged into the environment. So many, many RAS systems have filtration and ultraviolet treatment on their wastewater too. You need a good genetic stock, and that's where working with people at the USDA can help by having disease resistance or fast-growing stock. You have disease-free broodstock that you can then produce on site, and then you can use those animals to produce that high-quality product into the market that makes sure that your company has that amazingly good product that you want to sell. But of course, there's always risk, and everybody takes a risk just crossing the road. And how do you analyze it? Well, you analyze, and this is in the conceptual biosecurity bit, you do a hazard analysis and identify those hazards. And you have consequent outcomes and contingency planning when things go wrong. And you need to manage that risk. And you need to communicate that risk to your staff and your customers. And you can do this thing called HACCP, HACCP, Hazard Analysis and Critical Point Control, when you can actually enact those things within your work plan. And one of the questions I get asked is, there are always diseases outside. And if you're farming in the ocean, you're often risk tolerant. If you're farming RAS, you're risk adverse. So what you need to do is decide on the level of risk for each pathogen using a decision tree. If you get the pathogen, is it minor? You can treat it very easily, like white spot disease in fish. If you get the disease like sea lice on a salmon farm, it's going to have major consequences. And I mean, it said, we were talking about cost. For every pound of salmon produced, about 26 cents of that is on sea lice control. That's not just medicine, that's actually engineering to stop the sea lice settling, picking them off, making those fish welfare as high as possible. And then you can actually assess the risk regionally and nationally to yourselves and to the state using a risk evaluation table. And really you have the probability of a disease being introduced onto the system and the consequences of that introduction. So if the risk is high, but the consequence is low, it gets a score of around 9. If the risk is minimal and it's a negligible disease, it gets a score of 1. And of course, if that disease is a catastrophic disease where you would lose a large proportion of the animals and the high risk is there, you'll score a value of 9 times 9, which is 81. So you can actually get these mathematical models that estimate that risk. And that's a very simplistic one. There are many more sophisticated ones than that. But you can actually analyze that risk. And the reason I want to put that risk analysis in there is for my last slide of these koi carp. These are some koi carp. And Inland Fish and Wildlife in Maine have done a risk analysis for these, and they rate these high as an invasive species. So koi carp are banned in Maine, and it's the only state in the US where they are banned because the Inland Fish and Wildlife think that they could actually become established in the wild. So to conclude, biosecurity is important. You need to provide that high quality environment for your animals. You need to identify risk and practice risk reduction. You need a health plan with your veterinarian to make sure what happens with those diseases, you actually know how to treat them. You need to develop a good biosecure system. You need to use best working practices to reduce the risk. And quarantine is really important. Quarantine failure is probably the biggest cause of introduction into any form of farming, from cattle farming or agriculture, actually crop agriculture, to fish farming, to goldfish farming, to butterfly farming. Is that lack of quarantine that introduces the unexpected pathogen because you didn't do your risk analysis properly that is the biggest worry. So if you need any further information, please contact myself. Dr. Debbie Bouchard is the director of the Aquaculture Research Institute at the moment. Megan Dwyer is the associate director. And Kennebec River Biosciences are one of the world leading disease diagnostic laboratories, and they're based in Kennebec, in Maine, down in Topsom. Is it Topsom? Richmond. So we have a lot of resources here. And if you do want a copy of that book on biosecurity, drop me an email and I'll email it to you. I'm the only Bricknell in the telephone directory, so it's not a common name. So that was all I was going to say today. Thank you for listening.
You're assuming what? I'm sorry?
Premium prices.
Yep.
Do you think that farm-raised fish would also get a higher premium?
So will farm-raised fish be a higher premium in Maine as well?
Yeah, so I'll answer that from my experience at the MAA. The answer is yes, and we see that in other farm products. Some of the Maine shellfish that's farmed, we farm a lot of oysters in the state. We get a lot of premium products with that. As Jen gave the example with the Maine farm salmon and Hannaford's that you can see there, we do see a premium for Maine farm fish when it is labeled as, and people know that it's from Maine. And it's not always a price premium too. So a lot of times it's a choice. So people look at it and they go, I can buy a salmon from Chile that's farmed, or I can buy a farm salmon from Maine. They may cost the same, but they're more likely, surveys will show, to buy a fish that was farmed in Maine than they are to buy one from Chile or even Norway or Europe most of the time. So there's just that having the brand, and it sells this product in the marketplace over somebody else.
If I can add to that, I've been looking at diseases actually since the 80s, which makes me feel really old. But I've done lots of work with Asia, where they often have the reverse finding in their markets, where a lot of the farmed oysters and seaweeds and fish have a premium over wild because they know the freshness is guaranteed. It will be always so many days after harvest. They know that the quality will be the same. They won't have this variation in color or taste or whatever. So one of the things we haven't done well in the US is communicating those advantages of aquaculture along with the benefits of some of the wild caught. Unfortunately, we're in a bad position at the moment because most of our wild fisheries along New England are depleted. There aren't enough to go around, and we're importing around $20 billion of seafood a year from elsewhere in the world, and 60% of that is already aquacultured. So we should bear in mind that we actually could do that here in Maine and generate a good, healthy working waterfront again.
If I can just add one more thing to that, I think another reason that we look at this premium pricing for a wrasse salmon is that we know its entire history. Mm-hmm. We know what it's been exposed to. We know if there have been any issues with disease, but we also know that it's been given really clean, really good filtered water. Someone asked me a couple of weeks ago, well, does that mean your fish won't be exposed to microplastics like wild fish are? And I said, yes, exactly right. So there are a lot of other things in addition to being in the facility and feeding them that are benefits for land-based salmon that I think the people that are buying it and eating it are going to really like.
Any other questions? I'm happy to jump in with questions. I just don't want to.
What type of outside inspections will the facility have? I know like USDA will be doing inspections, I'm sure. Is there any other organizations they'll be accredited with?
I know that we need to have an outside audit for DEP. And in talking with some of the various agencies, there is a fellow who works for NOAA in Orono that has volunteered to be that auditor and go through that certification process. And that would be an inspection, I think it was once or twice a year. And that would include both the facility and our records of what everything has come in. And we would have to maintain records on site as well as off site. So there's a lot of oversight that goes into that, in addition to all of the water quality monitoring and testing that we'll be doing as part of the wastewater discharge license. And there's various quarantine plans, there's containment management plans that we have to have approved by DEP. Now that we have that license, there's all the supporting documents of how we're going to run our facility and how we're going to deal with problems that also have to be approved by the DEP. So we've got the license, but we've still got a lot of other things to fill in.
Yeah, so I'll just make one comment there on that. Seafood is different than all other farmed animals. Yeah, and so the USDA does not actually do food safety inspections for seafood. That actually falls under the FDA, who does it. I don't know why it's this weird, but it's the FDA who does seafood, and the USDA does all other agricultural products. So
There are also numerous quality assurance programs available which will certify the animals meet a minimum welfare standard or a minimum quality standard, which you may decide to join. And that's certainly beneficial as you expand your markets, because some countries like the European Union will require health certifications for every batch of fish that are sent out, plus analysis for a thing called MRLs, minimum residue levels, effectively to prove that there's no contaminants in that meat before it can be exported to those countries. So there's those kind of things to consider too.
One other thing is that it'll also be just as important what we feed the fish, which will determine where we can sell it. I know that Whole Foods has come out with some very strict requirements for seafood that can be sold in its stores. And in order to sell our fish at Whole Foods, which is something that we're looking into, we haven't made that decision yet, we would have to show that the feed that we fed them had no terrestrial animal byproducts. So chicken feather meal is something that is sometimes added to some aquaculture diets. It's a good source of protein, it's a good source of minerals. But if we wanted to sell in Whole Foods, we would have to certify that we were not having any of those products in our feed. And so those are decisions that we're making as we go through the process. And yes, we will be looking at those best practices certifications once we have our fish.
Yes, sir.
Along those lines, do you know where duck trap sources of salmon, and might they have the same kind of requirements as you're looking to provide?
So I'm gonna. The question was, do they know where duck trap gets its salmon from, and what kind of provisions it has for that? Right? Is that? Do you guys? I only know about duck trap because I've eaten it and it's delicious.
yeah, so I know the history, but I don't know currently. So they used to source their salmon from Atlantic salmon of Maine. I believe that currently they actually source it from out of the country, but I'm not sure where it comes from. That's what I thought, but I'm not positive. So,
ironically, I do all my teaching this semester. I actually checked the other day in Hannaford's in Hampden, and it said product of Chile on the packet I saw. So, yeah. I mean, our salmon is better and doesn't have 7,000 miles air travel on it. Sorry.
Oh, that's fine.
I would argue almost anything from Maine is better than anywhere else, but that's just my bias. So,
And I think that's definitely an opportunity in the future. I know that some people will have the fish fillet that they sell fresh, and then the trimmings is what they do for the smoked salmon. So there's a lot of opportunity there.
we can do one more. I don't want to keep anybody longer than they really want to be here. So, yes, sir.
Yeah, to be continued, I would say. We are looking, so we're building this in 3 phases. And phase 1 for us is what our current permits are, which is 5,000 metric tons of fish annual production once it's up and fully running. So we are expecting to have about 50 to 75 jobs for that phase 1, and that'll probably be about a 3 to 5 year process to get up to that full 5,000. And that's going to be front office, fish technicians, electricians, carpenters, HVAC, security, facility maintenance. I mean, there's everything. There's so many different aspects of a facility like this: engineering, science, research, fish health, water quality, that require a lot of different kinds of people with a lot of different education levels. And that's so one of the reasons that we're working with some different universities in addition to some different vocational avenues to make sure that we have programs in place so that people can get ready for these kind of jobs. Once we buy the property and once we have a better construction schedule, we'll have a better idea of when that first big wave of hiring will be. But Jason and I were just talking this afternoon about starting to get some job descriptions out there so that people can be prepared and start to look at what they might be interested in. So I would say late spring, early summer, we'll probably have a push to get that kind of a framework and that schedule out there. But until we really get the construction schedule lined up, I don't want to yank your chain and say we're going to do something when we're not. So we're getting there. Every day is a couple more things checked off the list. It's just the stuff at the bottom keeps adding.
I would like to thank you, all 3 of you, for spending your Tuesday night with us, and I would especially like to thank all of you for being here on a Tuesday night. Come join us in March if you enjoyed this. There will be serious talks like this, but there will also be things like the science of soda making. So you can kind of just little tease. There'll be everything you could possibly want with Maine. So thank you very much. Thanks to the Bucksport folks here for opening up their doors and letting us use their IT expertise. And please keep this in mind. And if you're interested in hearing more or having a follow-up on aquaculture here in Bucksport, I'd be happy to have another pop-up event here as we get further along and we can do a deeper dive into some of the other sciences behind it. Thanks.